My name is Justin Cormack, and I work at Docker in the Cambridge, UK office. We have an office here in Paris and in Cambridge, and as well as San Francisco and a couple of other places. And I've been recently working on LinusKit, which I'm going to talk about here. I also am a maintainer on Docker itself, and I work on a lot of the open source projects at Docker. So please ask me about them later on if you've got questions about Docker. I'm going to talk about LinusKit in a minute and why it's important for bringing containers to production, but I'm just going to start with a little diversion about immutability. Containers really taught us, that there's a good process for building software. You build your images once, you test it, you have your build pipeline automated, you deploy it. Ideally, it's a read-only. Then when you want to change what you're running, you change your code, you rebuild it, you retest it, you redeploy it, and you repeat this process. You don't log into your container that's running and do a little upgrade and change the software that's running in it and carry on or anything like that. And these old practices we used to do have kind of gone away, which is great because you understand what you've got running in production, you understand that it's passed all your tests, you understand what's going on. When you find a bug, you can test for that bug, you can make sure it's not going to happen again, and then you can redeploy your new code. We just had the demo just previously about setting up your build pipelines like this for containers. But what about your infrastructure? People generally, unfortunately, don't treat their infrastructure that they run their containers on the same way at all. People will deploy an AMI, and then they'll run some package updates, and then they'll run some configuration management code that will make some more changes. And maybe if you're really awful, you'll log in and make some more changes, and then you'll change your configuration management. And it's where's the point at which you're running tests? Are you sure that the thing you've deployed is what you think it is? What else did you change? When you reboot your servers, will they come back up? Do you know? And there's been people in the past who've said that this isn't the way you should treat it. Netflix, back in 2011, started working on the whole immutable delivery thing and saying, we're going to build servers once, deploy them, and if we want to make any changes, like containers, we'll just deploy a new server. And there's another quote from 2013, if you should really be building things by automation, because the scariest thing is a server that's been up for a while and has changed and you don't really know what state it's in. And you've got to make sure that your servers are, they're reliable. Everyone can fail at any point, and that you're not treating them as pets that you're looking after and fixing and upgrading. You've got to be more brutal about them. But this isn't really yet something that has been adopted everywhere. People, there's a I was a sysadmin for many, many years, and that's what much of my background is. And we had servers. You made jokes about your uptime, having an uptime on your server of a year, and even though there was probably, that meant that you hadn't upgraded it when there was last a big security issue. And then there's this kind of, you can call them the pet care industry, the vendors who, have a lot of tooling for these servers, and they really want you to buy their tooling and keep looking after your servers as pets and keep paying them money for running the servers as pets. So why aren't we all just treating our servers as proper disposable things like the cloud was supposed to bring us? And is the problem the tooling? The most popular piece of tooling for provisioning servers on a kind of repeatable basis is Packer, but it's basically using all the tools that we used to build servers with by hand in the background. And so we kind of LinusKit is a piece of tooling for people who really want to run servers in this kind of immutable way. Originally, we built this for Docker for Mac, which is kind of why I'm running a Mac at the moment still, because I worked on Docker for Mac when we started. And what we wanted with Docker for Mac was that you run a little Linux VM inside your Mac, and every time it starts, we want it to boot up really fast, just be there, run Docker, and you're not going to make changes to it. It's not even a user serviceable part. It just sits there, it runs Docker, it runs your containers, and then it goes away again. And it's managed by an upgrade process for the Docker for Mac, by the Docker for Mac app. It's not upgradable by the user. And then we extended this when we did Docker for Windows, Docker for AWS, Docker for Azure, Docker for Google Cloud. We did the same thing. We had this little VM and the little operating system we'd kind of built that was totally immutable. You redeploy it when you want to upgrade. And it was always meant to be open source, but we spent quite a lot of time not open sourcing it for various reasons. But we ended up turning it into this toolkit called LinusKit, which we open sourced at DockerCon just a few weeks ago now. And there's been a lot of community interest in it as an open source project. We've had lots of contributions, which has been really cool. And it really makes running immutable servers really, really easy. It's really simple to use. You can develop with it on your Mac or your Windows system as well as on your Linux system. It just takes a minute or so to build things. It just feels like, natural and fast. It's designed that you can build your server image in your CI pipeline. It's fast to boot, it's fast to test, immutable. It's designed to be managed by external tooling. We'll talk about that a bit later on. And it's really built from containers, built to run in the cloud. It's really kind of, modern and straightforward. The first thing, it's a simple YAML config. Everyone loves YAML. Everyone uses, everyone's used to YAML for Docker Compose and Kubernetes. And it's a sort of, the YAML config is sort of combination between a kind of Kubernetes pod and a Docker Compose file and a whole Linux distro. These are the kind of components that you can specify in your YAML file. What you want to run in your Linux system, what has to start up at the beginning, what services you want to run, which might be Docker or Kubernetes, or it might be a custom application you want to run, and some signing configuration, because signing packages is really important. So here's a really, really simple example. This is basically kind of the smallest little LinusKit example that will just run Nginx, and it runs Nginx straight from the Nginx Alpine Docker image that you can just download off Hub. So it's just you can just use any normal container as a package in LinusKit, and it has the only other thing it has is it has a DHCP container which sets up networking so that and it runs C and containerd because those are the basic packages that LinusKit uses to run containers in the first place. So this is really simple. It doesn't run Docker. It just runs Nginx directly in LinuxKit. And I'm going to show you this kind of live instead because we might as well. Let's do a demo. I'm going to use the almost exactly the same YAML file, just slightly. This is the default one that's just slightly more complicated. It's got a couple of extra services, but basically the same. We can do maybe build LinuxKit YAML. We're getting some errors about, because I'm not online, that from Notary saying that there might be a more recent version of your images, because it's not connected to Docker Hub, so it hasn't checked, but we can ignore them because we're offline. And we've built our first Linux distro. This is a bit quicker than installing Ubuntu or Red Hat. And then we can run it. Again, I'm running this locally on my Mac because I'm not connected to the internet. And you can see your Linux boot. It comes up, and here we are. And we can list the containers that are running. Just 3 little containers, random number support, Nginx, which is what we said we were running, and the Getty, which is the login prompt that I'm on here, which is actually running in a container as well. And we can see the processes. And we've built our first immutable Linux distro. It's there, and it runs. And we can deploy this exactly the same to Google Cloud or AWS. And we can shut it down. So you see, it's really, really straightforward. This is like there's no manual install process or deployment process. We don't have to run anything in the image. Everything is just built, and we can, change our YAML file. We can output an ISO or anything like that we want to do. So it's really, really it's completely and totally straightforward, and it'll find some way of booting on your machine. It'll run with HyperKit by default if you're running it locally on your Mac, or KVM on Linux, or Hyper-V on Windows, and then you can run it on any cloud platform, or you can run it on. It's got a whole lot of stuff built in, so you can produce different kinds of images. So you can produce QCOW images, the GCP compressed tar images, ISOs, various types of ISOs, and then you can just build, ship, and run just like a Docker container, except it's a VM image. You can push it to AWS and make an AMI. You can push it to Azure. You can push it to Google Cloud, make an image, run that, and you can push it to VMware, vCenter. You can run locally on VMware Fusion. You can make an image to run on other cloud providers like Packet.net, which runs bare metal. And the tooling here will let you configure networking and attach disks to the image and so on. So as you can see, our first little example was really, really simple. We just need basically two containers to run a simple Linux distro. That's obviously very simple, and often you want some other stuff. If you want to run Docker or Kubernetes, you need a few more containers. So we provide a bunch of stuff that you can use to make it easy to get started. Ways of configuring, formatting disks, reading AWS metadata to configure the server, NTPD if you need time synchronization, SSH if you want to log in with SSH, specific integrations for different platforms. So we provide all those in the LinusKit repo. Just check them out and use them. Or you can just substitute any other containers you want if you want to do it differently. The nice thing about having we provide a starting point, so if you don't know exactly what you want to do, you can just try it out and get started. Otherwise, you can customize it as much as you want. Nothing is required. You can remove everything from the YAML config, and it won't build anything, and it won't work. But you can replace absolutely all the parts with any bits you want. You can change the init system. We're still expecting someone to come along and run systemd on it one of these days soon, but no one has yet. And you can use any container. We tend to use multi-stage Docker builds to get nice minimal Alpine-based containers, which is because we tend to use them. And you can put labels on your images saying what capabilities and what security setup and what other setup your container actually needs, which makes the YAML files much easier to read. In the example we had earlier, this Nginx container, because it came off hub, didn't have the labels, so we had to put in all the capabilities it needed. But you can, for the containers that we ship, we add them in automatically, so you don't have to put anything in, which makes it easier to read and easier to kind of follow along. And then testing. So, you've built your Linux distro, and it runs your containers, does what you want to. The next thing you want to do is testing. We do two things really with LinuxKit. We create tests that include the container we want to test and a container that has the test code that runs against that. So you can basically we boot up an image. We boot up a whole VM that just does testing. So if you want to test that Nginx is running locally, for example, or that Docker is running locally, or that the kernel has the right settings that you want, you just boot up a VM that will run a test against that. And we do a lot of these. The test suite for LinuxKit at the moment has quite a large number of tests, and because it only takes a minute to do the build and run, you can basically run 30 or 40 tests by booting up different VMs in CI. We boot them up at the moment we either run them locally with QEMU on the machine that's doing the tests, or we boot up Google Cloud machines. Google Cloud's really nice because it's really fast to boot. They only bill you for 10 minutes at a time, so you can boot up a machine, run the tests, and shut it down, and it's all over really quite quickly. So, and it costs basically nothing to do that. So you can have your CI system booting up a whole bunch of images, testing each of the containers individually, and then you can also take your final image that you're going to run, and you can black box test it from outside. You can see, can I connect to it? Is it running Nginx as I expect? Is it running my application? Run the test suite for your application remotely on the whole image that you're going to run. Load test it. Load test that VM in your CI system, and so on. So you can do the two kinds of. You can either do component testing or black box testing, and ideally you do both of these. So it really becomes just like testing a container. It's the same process, it's the same build pipeline. You can you can run all your tests in the same CI system as you're using for anything else, and you can run lots of tests. You can spin these things up lots of times. You can build clusters of them for testing if you're testing a distributed application. So it really feels very much like working with containers, except that they actually images for running containers and for bringing containers to production. For deploying, you can use. We provide the simple LinuxKit run set of push and runs tooling. That's mainly designed for using for basically development and testing and using in CI. But it's not necessarily what you want to use for production. For production, the idea is that you can build any kind of image. So you build your AMI, and once you've built your AMI, for example, if you're deploying in Amazon, then you can use any kind of tooling you want. So if you want to use CloudFormation, that's fine. You've just got an AMI. It's an AMI. You deploy it, and it just works with the normal. Just like in CloudFormation, you can use the metadata services to get your image to customize itself based on metadata, configure your SSH keys if you're using SSH, things like that. You can use Terraform, so any kind of native tooling or general purpose tooling. We have a tool called InfraKit that we really like. It's a tool that was built at Docker, but based on an internal tooling that Twitter uses, and some of the developers who built it came to Docker to kind of rebuild it as an open source project. And we've done quite a lot of integration with LinuxKit, and we quite like it. InfraKit is designed for managing distributed applications that run on multiple machines. And unlike something like Terraform or something, it's not just I want to run this. It actively manages your infrastructure. So if you say I want 6 machines running, it will make sure that 6 machines are always running. It'll use the platform it's running on to monitor those machines. So it uses the state that's in the it uses the real state. So it'll query the Amazon API to see how many machines are still running. So if one of them's gone away for some reason, like it's crashed or whatever, it'll create a new machine. It can use etcd from Kubernetes or Docker Swarm to manage a distributed cluster of InfraKit machines so that it's reliable and maintains itself even when machines go down. It's got custom plugins for running distributed applications and for running Docker Swarm clusters, and we're working on Kubernetes deployment with it and things like that. So, and it supports things like rolling upgrades of, so you can upgrade your LinusKit, and InfraKit will do a rolling upgrade of all your machines to the new version, making sure they've all come back up with the new version. And it can do things like reattach the original disks that were attached to the machines when you do the upgrade, so they preserve the local state of your database when you do an upgrade and things like that. What the nice thing about InfraKit does is it can treat different groups of machines differently. So the etcd cluster you're running Kubernetes with has different requirements from some worker machines that you scale up and down all the time. So the etcd cluster must, for example, will always have 3 nodes, and when they come back, they need to come back with the same IP addresses, for example. So it can treat those differently from the worker nodes that are just scaling up and down with workload. And it can make sure they have persistent storage, they come back with the same IP addresses and things like that. And you can run 2 separate sets of rules for different machines and manage upgrades differently and things like that. So it's very good fit for this kind of infrastructure. As I said, it's totally optional, but we really like it. And there's some really cool demos with it, with LinusKit showing what you can do with upgrades. It can automatically rebuild machines. It can build custom LinusKit machines for different roles in the cluster and things like that. So it's really quite cool. Jesse talked about security earlier, and security is really important, obviously. It's your production. You're talking about production, and you want your production machines to be really, really secure. The NIST came out with their draft recommendations for running containers, and right at the top of there was use a container-specific OS, not a general-purpose OS. You don't want to run some general-purpose OS that has all sorts of applications that you don't care about. If you're running containers, you probably just want to be running the absolute minimum. You're going to be running Docker or Kubernetes on top of your container OS, and you're not really going to be running a whole bunch of other stuff. So use as little as possible and use something that's designed for running containers, something that's small, something that hasn't got the attack surface. With LinusKit, you can specify exactly what you want, and nothing else will be run. It's really straightforward from that point of view. You can absolutely see that the config file corresponds to what you want, and it's not going to add in some 300 dependencies from something that you haven't really thought about. There's no dependencies. Everything's container. The container runs. It does what it wants, and what you specify, and it doesn't bring in, I just need to run a mail server as well because you installed something that the operating system thinks requires a mail server, because historically it used to require, people used to run a mail server, and then you're running a mail server. Why are you running a mail server? That's it's really important to only include what you want, what you need. A modern kernel, as you saw in my example I had earlier, we were running 4.9, Linux 4.9. We've been running that as the recommended kernel for LinusKit for about 6 months now. And there's test kernels available for more recent ones, so we have 4.11 kernels available for which you can also run. We provide 4.4 kernel as well, but that's already quite old and is only supported till the end of this year, so wouldn't recommend that. But yeah, we do. We provide a absolutely modern kernel, and the Linux kernel development process means that unless you're running a modern kernel, you're not going to get all the security fixes. I mean, people backport them, but it's a much slower and less reliable process. And you get all the new security features as well in the new kernels, which are really useful. We're spending some time rewriting the system services that you do need, the minimum ones, in type-safe languages like Rust and OCaml in particular, so that all the bits you still have to run are as secure as possible. Because we've got a small base, we can spend a lot of time testing what there is. We're running fuzz testing on things to make sure that they, all the components that you have to run are as secure as possible. All the services are running in containers, so they can run with minimal privileges and minimum access to the rest of the system, isolated their own PID namespace. So again, we can reduce privileges and use the tools that you're already using for containers anyway, so may as well use them in the rest of the system. There's a bunch of new security technologies we're planning on shipping in the future, which I'll talk about in a minute. If you're interested in security, we have a security special interest group which meets every 2 weeks. I think the next one is next week. I'll show you the links for where to, if you're interested later. And we're working on getting a whole new set of things tested and shipped in future, which I'll talk about in a second. One of them is a really interesting project that I think I'm really interested. I picked two. We've got a whole bunch of security things. I picked two that I'm really interested in, the ones that I kind of think that are going to make them a really big difference to how we run containers. So WireGuard is a really, really lightweight kind of VPN in the Linux kernel that's designed to replace IPsec and other VPN code in the kernel in Linux. And it's, by lightweight, I mean a few thousand lines of code using it's maybe 100 times smaller than IPsec, which is this giant specification with all sorts of issues. It's really simple and designed for containers. So you create an encrypted interface which you can then give to a container, and the container can only talk. It can only send encrypted network traffic. It can only send it to endpoints it's authenticated with, and it has no access directly to the external network. So it basically sits there with just a secure network tunnel that it can just talk to the other containers that have the matching set of keys. And so this, I think, can really change how we manage container networking once we get it. It's a very simple kind of key exchange like SSH. It's really simple, easy to use. It's not, but I think that it's the kind of way that we would like to see container networking be in future. Is not, it's basically you specify how you want to be able to access another container just by giving them a pair of keys they can mutually communicate with, and no other container can talk to this container unless it has the right keys. And it's potentially a much simpler network security model for containers. There's a whole bunch of work we need to do to get this integrated with container systems, but the first thing is to test the basic stuff, the kernel modules. So there's a project in LinusKit where you can install the tooling, and over time we'll expand that to a whole proof of concept for how that will work for container networking. I'm hoping to work on that over the summer, because it's really good fit for container networking, and I think it's going to that's the kind of model we really want to be moving towards. The next project I want to talk about is Landlock, which is a complete implementation of a Linux security module that's, again, it's perfect for containers. Jesse talked earlier about SE Linux and AppArmor and SecComp. And in a way, this basically is a kind of combination of the three of those into one custom security module that's designed to be ideal for containers. It's based on BPF like SecComp, but the problem with SecComp is it gives you very little information when you actually have to make a decision to allow or deny something about what's really going on. So, for example, when you open a file, SecComp doesn't give you the file name that you're trying to open, which is kind of useless. And when a lot of the time when you want to, sometimes when you're opening a socket, it doesn't even give you what type of socket it is. Sometimes it does. It's depending which system call you use to open the socket. And so there's all sorts of problems with SecComp in terms of making really the kind of decisions that AppArmor and SE Linux can make. Landlock hooks into the same authentication points as AppArmor and SE Linux, but you can write a custom program for each container that can make the decision on whether to say yes or no for whether the container is allowed to do that. So each container can have a separate customized policy. It'll effectively replace SecComp, and we're hoping it should be merged into the Linux kernel sometime, hopefully this year. There's a guy in France who's been working on it, who's developed it originally, who's been going through the iterative process of getting it acceptable to the kernel community, and I think it'll get there sometime, hopefully this year. But you can, again, you can try it out in LinusKit, and again, this is something that we're going to have a whole set of prototypes around, so you can see how it works, work out what kind of policies we want to write, how to customize them, and work out how we're going to integrate this with container platforms in future, and get that work ready so that once it's merged into the kernel, or even before that, we can start using it and trying it out and making really nice custom manageable security policies, which I'm really looking forward to. Again, it's something that I want to spend some time on, because there's so many problems with the current policies that we've got, and having a single policy that you can write one program to implement is really, really exciting. Get involved. I mean, LinusKit's an open source project. We've had loads of community involvement. Things like the VMware support has all been added by community members since we open sourced it, which is really great. We've got people adding all sorts of things they want to run. We are currently rebasing the Docker for Mac and Docker for Windows and Docker for AWS and so on the new open source version. And as part of that process, we're releasing lots of bits of code that we use to build those platforms, and kind of blueprints of how we run that code for those platforms. So we're doing that over the next month or so, a couple of months. So you'll be able to see exactly how we run LinusKit in production and use that to run your own stuff in production. And we'll have full kind of worked examples of how everything fits together. The Mac ones are being integrated at the moment. There's some really cool features. All the features that are built into Docker Mac, you can see how they're built internally with LinusKit. So things like the port forwarding to the local machine, and accessing the Docker socket from the local machine, and all that code is all integrated and has working examples of how you can do that with other custom containers. So you can build your own tooling that does the same kinds of things, and there'll be more of that with all the other Docker platforms. So you can see how we run stuff in AWS and Azure, all the integration with all the platform integration for the different cloud providers and things like that. So there's lots of work going on, and there's a Slack channel which is pretty active, where people ask questions, talk about what's going on, what they want to work on, and things like that. We publish weekly reports every week, so you can see what's going on in the development, what's all the things that have been merged in the week, because there's a load of activity. You can I'm not online, am I? I keep forgetting. I should have logged in first. And you can follow us on Twitter. That's me or the Moby project. And so there's as I said, there's security SIG if you're interested, especially in the security parts and what's going on there and how they might be integrated with things down the line. We've got companies like HPE are contributing container isolation with using virtualization features, which is really cool, which they're working on and integrating. And we've got ongoing projects to do things like rewrite system services in Rust, which are going to be, and Camel as well, which are reporting in the security SIG. So loads of stuff going on. Or just come to the repo, check it out. It's really easy to use and install. There's now a homebrew repo on the Mac, so you can just install it, run it, try it out. And we're hoping that that people will start outside Docker will start using it to run their containers in production really soon. I've got time for questions, so as well. So, have we got a mic for?
Hello. So I wonder, can I have control on which modules are included in my Linux kernel if I build a LinusKit image? And same question for device drivers. If I want to really reduce the surface attack, I would like to remove everything that is not useful at runtime.
Yes. You can we have a default kind of kernel that we maintain with a default set of drivers, which is actually relatively minimal and mostly not modular. But you can basically run any kernel you want. The kernel is a container image that just contains the kernel and a tarball with the module directory that you want to use in. So you can absolutely customize it exactly how you want. And we're trying to work on one of the projects we got is a framework to make it easier to change the config and make it easier to customize, so that it's easier for people to do exactly what they want. But it's everything's totally customizable. The kernel we have is kind of what we've been using for the Docker editions, pretty much. So it's but it's fairly general purpose. But we've got some people who are really interested in making kernels that are really, really cut down and can only run exactly what you need. We've got, which is as well. So yeah, absolutely. You can also run. We have packages for the Ubuntu and Debian and CentOS kernels as well, if you want to run them. But yeah, completely. Yeah, everything is customizable.
Hello, so if I got it right, you're essentially taking a base image comprised only of the kernel and customizing it. So in this case, why did you create yet another image building and configuration description tool instead of contributing maybe something to Packer in form of a new provisioner to handle that?
We spent some time looking at Packer. The complicated thing about Packer is that the provisioner has to actually run inside a booted image, and that kind of makes it a lot more complicated. One of the requirements that we had was that you could run everything to build your image without booting the image first, which makes it much quicker. So as you can see, when I built my image, it literally took maybe 20 or 30 seconds to build, and that's it. And so, whereas if you have to boot it and then run some code inside it, it makes it much more slower and more complicated process. It kind of so it kind of reverses the process that you know what you want, you specify the end bit, and then you just build that up from scratch. And it's kind of it makes the whole thing much simpler. So, and you don't have to have a package management system inside the image at all, because it doesn't have to be able to, these images are designed to be immutable from scratch, so you don't have, whereas, with the provisioner, you'd have to go and install packages, so you have to have a package manager in the image to start with. This way, you don't have a package manager in the image at all, you just build it from scratch.
Okay, thanks. And second question, do you think it's really relevant for most of people to build their own Linux distribution instead of using a minimal container-based one like CoreOS?
I think that it depends what you. We aim to provide a bunch of stuff that's ready to go. So you won't have to necessarily build and customize it yourself if you don't want to. So we'll have images that are kind of ready to go. But if you want to customize it or you want to do other things, it's much easier than customizing CoreOS. CoreOS is kind of most people don't customize CoreOS because it's difficult. Versus this, you can customize it because it's easy to customize. It's just it's a different kind of approach, and you can make something that's much more minimal than CoreOS, and much simpler, or you can, and it's easier to add packages because packages are just containers. You can just have something that's pushed to Docker Hub. That's immediately a package you can install. You don't have to, build anything else. So it's a different approach.
Thanks.
One last question, maybe quick.
It was my understanding that you could bootstrap a cluster of LinusKit with InfraKit.
Yeah.
And I would like to know, does LinusKit allow you to manage a swarm or maybe a SwarmKit cluster at the moment?
Yeah. So InfraKit has a Swarm plugin built in. It's not built in because nothing's built in, but it's an option. It's got an option for managing Swarm clusters, which is what we use for example, Docker for Google Cloud uses the InfraKit Swarm management, and so that'll maintain the master node separately from the workers, and it'll do the configuration thing to start up and join the cluster at the beginning, and it'll allow you to scale the workers separately, and it'll do all the complicated work of if one of the master nodes dies, it'll rejoin a new master node into the swarm for you, and so on. So it's pretty. we'll have some more. I want to do some more examples of that in the documentation because it's. But yeah, it absolutely does work, and it's really, and we're using it in production. I think yeah, it definitely needs some more worked examples of how to do it. And so we'll do those. We'll definitely do those because it's because there's actually quite a lot of it's not the easiest thing to boot a Swarm cluster or for that matter a Kubernetes cluster or anything. So we definitely want to have full worked examples of how to do all that. But yeah, no, it's there, and that's the kind of use case that InfraKit was designed for, of these kind of more complicated clusters where you have different types of nodes and they have to be managed differently and they have to be upgraded differently, and they have to be treated in the right way. Some of them have persistent disks, some of them don't have persistent disks, and some of them need fixed IP addresses, and some of them don't. There's all these things that you have to do, and the bootstrapping sequence for Docker Swarm is quite complicated because you have to boot up one node, then you have to read the join key from that node, and then you have to give it to the next node. So that kind of thing is more complicated, and so it's absolutely designed to do that. There's some bits of examples in the InfraKit repo, but we'll definitely do a whole worked LinusKit example for that soon because it's definitely non-obvious and